Hello everyone, welcome to the channel Amazing Civil Engineering Studies.
Hello friends, in this video we will study about
building construction step-by-step process, building components of building, building construction step-by-step process. Building a construction step involved in any type of construction is not an easy task. Perhaps it requires lots of effort and investment. Although, for building construction requires lots of time and it is tedious work, yet its result is a permanent asset for us. Therefore, care should be taken in building construction process. Before planning, building construction projects must consider important aspects like the purpose of construction, utility, financial proficiency, the demand for work, etc. Construction of residential building required following paperwork before the start of actual construction. These steps are of pre-construction phase. To acquire land or plot. Preparation of drawings as per requirements of consumers. Estimation of material cost, labor cost and contingencies. Approval of drawings and estimates from client. Approval of drawings from City Development Authority. It is most important because residential building drawings should meet the authority-defined rules. Start of construction work either through contractor or labor hired on daily basis. Marking of plot boundaries. Cleaning of plot. Preparation of site layout as per drawing. To acquire land or plot. It is the most important step in building construction. Search for the location for the building which is best suited for building construction purposes. Be careful while selecting land which has all the desired facilities available nearby and should be free from all land-related issues. It is suggested that do prior data collection before buying land or plot either by doing research online or seek help from real estate agents or concerned persons regarding the effective cost of the same. To seek technical help. After selecting proper land for building, take the help of a professional architect to create building designs and take his/her advice. An architect prepare plan as per building requirement, number of flats, shops based on your requirements and budget. Then after architect consult with a structural engineer for details of the reinforcements to be used, how deep your foundation will be, the size of gravel to be used, pillar width, etc. Preparing estimate and budget. Building construction involves a huge amount of material and budget. After planning and structural detailing completed, these details are transferred to the building estimator. The building estimator will estimate the material quantity of different items of work, and prepare an abstract sheet that shows the cost of building construction. If financial resources are limited, we need to seek pre-approval for loans in advance or else you may end up in a cash crunch situation. Permission from authorities. This is important work to do after the project is ready to be executed. For that, we have to take permission from the local municipal body before you could go for the construction. Following are the list of document project required before applying for permission. This document may differ from state to state, but some are essential for every building construction work. Land survey. Survey of the land has to be carried out with the help of authorized land surveyor. Soil test report of the land. Land documents. Architecture/elevation/sectional drawings. Structural report. Architect certificate of undertaking on record and certificate of the undertaking of civil engineer on record. Approach a builder. A builder or contractor for construction must be chosen carefully because it is a major factor for securing building construction quality and timely construction of work. Pre-investigation must be done about the builder before handing work. In the contract document, all the work-related details must be clearly stated. The contract document should cover layout and work details along with the payment methods, time scales, and costs. The condition of the contract should be thoroughly checked before signing a final deal. Building construction steps. During building construction steps. Site preparation or leveling work. Excavation and PPC. Foundation. Plinth beam or slab. Superstructure column. Brick masonry work. The lintel over door window gaps. Floor slab or roof structure. Door window framing and fixations. Electrical and plumbing. Exterior finishing. Terrace and roof finishing. Internal finishes. Woodwork and fixture fittings. Site preparation or leveling. The construction site must be cleaned before the work is executed. This work involves the removal of roots of trees, debris, and leveling ground area. Earthwork. Generally, excavation is carried out for the construction of wall foundations. Excavation should be carried out as per the drawings defined lengths and widths. After excavation, lay out the foundation and backfill the remaining excavated area around foundation with soil. Floor levels of residential buildings are higher than the natural ground level. Fill the area with soil up to floor levels and compact the soil. Now earthwork of residential building is finished. Excavation and PCC. The foundation of building ground is excavated with the help of excavating machines as per the building dimensions specified in drawings. In this foundation trench, a layer of PCC, plain cement concrete, is laid in the dug portion before placing the reinforcements for the foundation. Foundation. The building is supported on the foundation is the lowermost part of the building that is in contact with the soil. A building is load transferred from the superstructure to the soil and needs to be extremely strong to handle the load. After the PCC work, foundation reinforcement work is started. The foundation bottom level must check before concreting it. The remaining space between the foundation is filled with earth. Concrete work in foundation. It is very necessary to check the levels of foundation before concrete work. There are patches where excavated depth slightly exceeds and vice versa. Level the foundation base to same level. Now pour the concrete as per drawing specs. Generally, concrete of ratio 1:4:8 is used for foundation. Sometimes it is even 1:5:10 or 1:6:20. Here 1:4:8 means 1 part cement per cubic, 4 parts of sand per cubic, 8 parts of coarse aggregates. Depth of foundation varies from 9 to 18 and normally for most of the cases it is considered as 12 depth. Keep foundation width equals to its depth. Damp-proof coarse, D.P.C. To protect walls from moisture, a layer of damp-proof coarse material is laid down at floor level. Thickness of this concrete layer is 0.1 inch. Material of damp-proof coarse layer consists of concrete ratio 1:1.5:3 with a mixture of waterproof material 1 kg bag. Plinth beam and slab. After the foundation work is done, ground beam formwork preparation is started and poured with concrete. Over the plinth beam, masonry work is started, and space between foundation and plinth beam filled with soil. Superstructure column. The superstructure is the portion above the plinth level of the building. The main component of the superstructure is a column and beam. The columns are built up to slab level and the frame for further construction is prepared. Brick masonry work. As column and beam framework completed, masonry work is started with different materials such as bricks, concrete blocks, fly ash bricks, etc. according to building drawing. Masonry work is done using a cement mortar mix. It is a mixture of cement and sand. During this, carefully and as per drawing, gaps are laid for doors and windows during the masonry work. Masonry work is carried out with cement mortar. Cement mortar is a mixture of cement and sand. Ratio of cement mortar varies from 1:4 to 1:6. Here, 1:6 mean 1 part cement and 6 parts of sand. Dampen about 25 bricks with a hose pipe and clean away all loose dirt from the top of footing and moisten about ammeter of surface at one end of the foundation with the hose pipe. Throw mortar line just behind the threaded level line and lay bricks on the mortar bed. Make sure bricks exactly follow the threaded horizontal level line. The lintel over door window gaps. The lintel is constructed on the door and window to support the masonry work over it. After this, further masonry work is done. Masonry work of buildings is carried out in one go till roof. Openings for windows and doors are left during masonry works. Reinforced cement concrete beams are laid down on the top of openings. So, those loads of structure above openings not directly come onto the door frames. Roofing. Roof slab of building is poured after completion of masonry works. Nowadays, roofing is of reinforced cement concrete slab. Slab thickness and reinforcement details should be according to approved drawings. Floor slab or roof structure. Then the formwork is started to construct slab resting on the column and beam. Over slab formwork, slab reinforcement is placed as per slab detailed drawing. Door window framing and fixations. After that, door window frames are fixed at their specified position given in drawing. Doors and windows. Traditionally, doors and windows of woods are used. But, steel and aluminum is also not a bad choice. In case of wooden doors and windows, frames are fixed in walls during masonry work. Panels are then fixed with hinges after plaster work. Steel and aluminum doors are fixed after completion of paint work. I will discuss the doors and windows types after this. Electrical and plumbing. As we know that buildings are constructed with a clean finish in which electrical and plumbing work is not visible. They are installed in the walls and slabs such that they are concealed and not visible after the finishing work is done. The point and pipe end left out such that later they can be finished with the electric fitting and plumbing fixtures. Exterior finishing. Once this work is completed, external plastering and finishing work is started. Waterproofing is also done to prevent rising dampness in the wall. External cladding can also be done to enhance the elevation of the house. Plastering and pointing. Form work is removed after 14 days of slab pouring. Now plaster work begins. Mortar for plaster work is generally of 1:3 or 1:4 is used. Thickness of plaster layer should not be more than 0.75 inch. Cure the surface about 7 days. So that plaster gain proper strength. Generally, internal walls of buildings are covered with plastered layer and external walls with pointing. It is better plaster the external walls rather than pointing. Terrace and roof finishing. On top of the slab, waterproofing is done to prevent any leakage in the slab. Generally, terrazzo tiling is done to prevent the slab from a weathering effect. Internal finishing. Internal walls are plaster with smooth finish and flooring is done with tiles. Later on, the walls are painted or textured. Woodwork and fixture fittings. By following the above step, almost construction work is completed and then after furniture work is started. Side by side, electrical fitting, switchboard, and plumbing fittings are complete in the bathrooms and kitchen areas too. The last step of building construction is interior decoration work in completing the building construction with proper furnishing and fabric used. Services are very important for every single house. Different types of services are provided during construction. These are electricity supply, gas supply, water supply, sanitary etc. Conduits for electric supply are fixed in walls before plastering. Similarly, water supply and sanitary lines are also laid before pouring of building floor. Note that gas lines are not fixed in walls or slabs. Gas line remains open in air. Structural components of building and their standard dimensions. The structural components are essential elements of any building. Without this structural building not able to stand and sustain its position on the ground. This components systems provide strength, stability, support, and durability guarantee in structural components systems. Following is list of building components. Foundation, plinth, earth filling, DPC, damp-proof coarse, flooring, walls, RCC column, sill level, lintel, ceiling, Chhajas, RCC beam, roof or slab, doors, windows, parapet walls, waterproofing on terrace, copying, structural components of building, foundation. A foundation is the lowest part of building structure rested on soil below ground level. All loads of building transferred to foundation through beam and column arrangement. Its main function is to distribute the load evenly and safely to the ground. In framed structure, footings are generally used as foundation to support structural load of building. Following are various types of foundations and footings used in construction. Shallow foundation, individual footing or isolated footing, combined footing, strip foundation, raft or mat foundation, deep foundation, pile foundation, drilled shafts or caissons. Standard dimensions. Foundation size, depth totally depends on the structural and site ground condition. So, there are no standard dimension recommendations for it. But, for small structural like row houses, depth of foundation should be at least 1.5 m from ground level. Plinth level. Plinth level or plinth is the offset created between ground level and superstructure of the ding. It is made by constructing a brick wall from ground level to the ring level of the building. Its main function is to prevent the entry of moisture from the surface to the building superstructure. Standard dimensions. Plinth height of any building must be at least 45 cm from the ground level. Earth filling. An earth filling or soil filling is done between the plinth wall. It is essential to fill the open space left between the ground level to the plinth level. Earth filling must be very well compacted, so that the flooring gets sufficient hard surface base. Standard dimensions. Earth must be filled to the top of the plinth level. Different materials can utilize as earth fill like soil, coarse aggregate, waste materials, brick bat, etc. DPC, damp-proof coarse. DPC is all layer of waterproofing materials such as asphalt or waterproof cement at the plinth level. The superstructure walls are constructed above the DPC layer, so that no dampness rises from the ground surface into walls. In short, DPC present the rise of water to superstructure. If dampness rises in the wall of the superstore, it reduces the strength of the walls and creates unhealthy living conditions. Also, it created many defects in paint and plaster and ultimately increase maintenance cost. In the case of plinth, beams are provided above ground level. DPC is not required. Because plinth beam itself performs as a DPC layer to restrict the entry of dampness. Standard dimensions. Generally, DPC is laid on brick masonry construction up to the plinth level. So the width of DPC is the same as the width of the brick wall, and thickness may vary from 2.5 cm to 5 cm. Flooring. Flooring is an important component of the home. It is one which provided an attractive and pleasant look to the house. Flooring is made by laying tile on it. There are different designs and materials are available to make flooring. 1. Timber flooring. 2. Laminated flooring. 3. Vinyl flooring. 4. Porcelain or ceramic tile flooring. 5. Natural stone flooring, marble, granite, etc. Standard dimensions. Flooring is provided above earth filling with base made of cement concrete, 1:2:4. Flooring material should have sufficient thickness and strength. Walls. Walls are the vertical component in any structure. It can be constructed using stones, bricks, concrete blocks, etc. The different types of bonds are used for constructing walls. Bricks walls are essential to enclose the inside area and protect against wind, sunshine, rain, etc. Doors and windows are provided in the walls for ventilation and access to the building. Standard dimensions. Walls may be made single brick walls or double brick walls. The single brick wall has a thickness of 100 mm and the double brick wall has a thickness of 230 mm. RCC column. Columns are vertical members constructed to support any structural frame. Load coming from the slab, beam transferred to column, and column transfer load to the footing safely. Building structure may have two types of columns, architectural columns and structural columns. Architectural columns primarily used to increase the aesthetic appearance of building, while a structural column takes the load coming from the slab above and transfers safely to the foundation. Standard dimensions. Column may have various sizes as per the structural load requirements. But, for minimum dimension for any structural column is restricted to 9x9 or 225 mm x 225 mm. Sill level. It is the base point of any window in the house, or it is a level where windows are placed. Sill level is very important to ensure evenness in all window level. Sill is a height which is ensuring that the proper amount of light enters in the house. It also provides easy to habitant to look outside through the window without any discomfort. It provides a solid base for window installment. Standard dimensions. Sill level of any house should be around 3 feet or 900 mm. Lintel. Lintels are constructed from reinforced cement concrete. It is provided above the wall openings like doors, windows, etc. The lintel actually takes the load coming on window and door openings. In short, lintel safeguard the door and window from excess load coming from above. In residential building, lintel can be constructed from concrete or brick masonry. Standard dimension. Generally, the lintel width is the same as the width of wall and thickness between 4 to 6. Ceiling. Ceiling is not a separate part, but is a bottom face of any slab. Ceiling is most important part of any room, because it can be decorated to increase aesthetic appearance. POP, plaster of Paris, is a material used for making false ceilings. It is a location where we can hang decorative items, fan etc. to increase architecture view of room. Standard dimension. Ceiling height is kept 9.6 to 10.6, it can be more or less as per requirement. Chhajas. Chhajas also called as weather shed. This is a structure which is constructed above window projected outside from window face. The main function of weather shed to restrict the direct entry of rain water and sunlight. Chhajas are constructed from reinforced cement concrete. Standard dimensions. The length of chhajas equals width of window plus 0.15 m bearing on both side. Width of chhajas equals 0.45 m to 0.60 m. RCC beam. RCC beam is important component in any frame structure. Beam is horizontal member which connect column on both side. Its main function is to take load from upper structure and transfer it to column. Generally, column to beam connection is called direct support while the beam to beam connection is called indirect support. In most of cases the beam supported by two columns and the most rarely used is the cantilever beam. Standard dimension. Beam minimum dimension is 9x9, thumb rule. Roof or RCC slab. Roof is an essential component for any structure, which provides protection against environmental factors like sun, wind, and rain. Generally, all roof rests on sidewalls and required anchoring so that wind and another mechanical impact cannot destroy it. Roof may have different shapes, but flat and sloped roofs are more popular. Typically most of roofs are constructed from RCC, stone slab, tiles, etc. Standard dimension. Generally, RCC slab thickness can have minimum dimension 4 to 6 as per requirement. Doors. Doors are the main entry and exit point of any house. Without doors, there will be no security in house. They are one which separates the one room from others. Doors have lock key facility, so we can lock the house by locking the door and go out freely. They are made of strong material like steel, wood, iron. Therefore, they are not easily breakable. There are different types of doors used in house. Hinged doors, Dutch doors, roller doors, bifold doors and many more. These are discussed below. Standard dimension. Main door of the drawing room, bedroom, kitchen may have a width up to 2.6 to 3 and other rooms like bath, W/C is 2 to 3. Height of doors is almost 7 every time or up to lintel level. Windows. Windows are one of an essential component of any house or building. It is one that allows fresh air and light to enter into the house. Without window, house becomes darkroom or jail. Windows are provided at sill level and their height extended up to lintel level. There are various types of windows used in house like single hung windows, arched windows, awning windows, bay windows, Bow windows, casement windows and many more are discussed below. Standard dimension. Window opening width may change depending as per requirement, but its height generally kept 1 point from sill level or up to the bottom of the lintel. Parapet walls. It a low height wall built along the edge of the roof, terrace, walkway, balcony, etc. Parapet walls can be constructed using different materials like reinforced cement, concrete, steel, aluminum, glass, etc. It is generally constructed with single brick wall. Standard dimensions. Parapet wall height is 3 fet or 0.90 m. Waterproofing on terrace. Damp-proof coarse is the protective layer to restrict the movement of moisture, water through roof slab. For DPC on roof, flexible materials are used which provide a lesser number of joints like mastic, asphalt, bitumen felts, plastic sheets, etc. Coping. Coping is structure which is constructed on top of boundary walls and parapet wall, etc. To protect rainwater directly store on brick masonry wall. The main function of coping is to drain off rainwater during the rainy season and improves the aesthetics of the structure wall. The standard room size and location in residential building. What are the standard room size and location in residential buildings? In this video, you come to know about the various standard dimensions of different elements of residential houses. Area limitations. The limitation of area and height of the buildings of different types of construction and occupancy is achieved by satisfying floor area ratio, FAR. FAR is taking into account the following aspects. Occupancy class, type of construction, width of the street fronting the building and the traffic load, the density and locality where the building is proposed, and parking facilities, local firefighting facilities, water supply and drainage facilities. Floor area ratio, FAR, equals total cover area of all floors/plot area. The floor area ratio for residential buildings is ranging from 1.0 to 2.0 depending on the type of construction. It restricts the height of the building and the number of stories provided. For example, if a plot measures 15 m x 20 m and building bylaws stipulates permissible FAR as 2.00, then the maximum built-up area which can be put on the plot is 600 square meters. If the area covered at ground floor is 150 square meters, the total number of floors that can be constructed is 600. 150 equals 4. Thus, with these bylaws, the height of the building cannot be more than 4 stories. FAR is also used in classifying the type of construction on the basis of resistance offered by building against the fire. Height of the building. The height and number of the story for a building are related to FAR, and the provisions of open spaces are already explained earlier. Where the building height is not covered by FAR, the maximum height should be limited to the width of the street as follows. The maximum height of the building shall not exceed 2 times the width of road abutting plus the front open space. if a building abuts on two or more streets of different widths. The building shall be deemed to face upon the street that has the greater width, and the building height shall be regulated by the width of that street and may be continued to this height to a depth of 24 ma along the narrower street, subject to the conformity of open spaces. In the vicinity of aerodromes, the maximum height fixed in consultation with civil aviation authorities. Appurtenances like a water tank on the roof, ventilating and air conditioning appliances, lift room, chimneys, and parapet walls not exceeding 1.2 minutes height are not included in the height of the building. Standard room size and location in residential building. Minimum area, 9.5 sq.m. Standard living room size 9 feet x 10 feet. Minimum size of side. For one room, minimum width should be 2.4 m. 2. Where there are two rooms, one of these shall not be less than 9.5 square m and others not less than 7.5 square m with a minimum width of 2.1 m. The standard room size and location for different types of room. Bedroom, living room, drawing room, dining room, study room. The height of room, the of all room for human habitation, shall not be less than 2.75 m measure from the surface of all floors. Other requirement, for air conditioning, room height should not less than 2.4 m. The recommended standard room size and location for the living room of various sizes are as below. Size. Dimensions in meter plus area. Dimensions in feet plus area. Large 6.71 times 8.53, 57.24. 22 times 28, 616. Medium 4.88 times 6.01, 29.33. 16 times 20, 320. Small. 3.66 times 5.49, 20. 12x18, 216. Very small 3.05 times 3.66, 11.16. 10 times 12, 120. Kitchen. Minimum area, 5 sq.m. Minimum size of side, the width of the room is not less than 1.8 m. Where there is a separate store, the area of the kitchen may be reduced to 4.5 square m. A kitchen that is intended to use as dining also shall have a floor area of not less than 7.5 sqm with minimum width 2.1 m. The height of room, the kitchen height shall not less than 2.75 square m. Other requirement. Its floor should be impermeable. Unless separately provided in a pantry, means for washing of kitchen utensils which shall lead directly or through the sink to a grated and trapped connection to the waste pipe. The recommended standard room size and location for the kitchen of various sizes are as below. Size dimensions in meter plus area. Dimensions in feet plus area. Large 3.65 x 6.09, 22.23. 12 x 20, 240. Medium 3.05 x 4.87, 14.85. 10x16, 160. Small 3.05x 2.44, 6.10. 10x08, 80. Very small 2.13x 2.75, 5.85. 07x09, 63. Bathroom and water closet. Minimum area, 1.8 square meter. Bathroom, 1.1 square meter, WC. Minimum size of side, if bath and water closet are combined, its floor area shall not be less than 2.8 square meter. With minimum side width of 1.2 m. The height of the room, shall not less than 2 m. Other requirement. It should be located such that at least one of its walls open to the external wall. It should not be directly over or under any other room than another latrine, washing place, bath, or terrace, in case of multi-storied buildings unless the floor is watertight. It should have a platform or seat of watertight, non-absorbent materials. It should be provided with the impervious floor sloping towards the drain with a suitable grade and not towards veranda or any other room. The recommended standard dimensions of common bathroom of various sizes are: size dimensions in meter plus, area. Dimensions in feet plus, area. Large. 2.13 times 3.66, 7.80. 7x12, 84. Medium. 1.83 times 3.05, 5.60. 6x10, 60. Small. 1.52 times 2.75, 4.20. 5x9, 45. Very small. 1.06 times 1.98, 2.04. 3.5x 6.5, 22.75. Storeroom. Minimum area. The minimum area of storeroom should not be less than 3 sqm. The height of room. The storeroom should not be less than 2.2 m. The recommended standard dimensions of storeroom of various sizes are as below. Size. Dimensions in meter plus, area. Dimensions in feet plus, area. Large 3.65 x 4.26, 15.55. 12 x 14, 168. Medium. 2.44 x 3.05, 7.42. 8 x 10, 80. Small 1.52 x 1.83, 2.80. 5 x 6, 30. Garage. Minimum area. The minimum area of garage should not be less than 12.5 square m. The height of room. The garage should not be less than 2.4 m. Staircase. Minimum size of side. The minimum width of the stair is 1 m. The height of stair. The minimum clear headroom shall be 2.2 m. Other requirement. The minimum width of tread without nosing shall be 250 mm for residential buildings. The maximum height of rising shall be 190 mm for residential buildings. Plinth height. The height of the plinth shall not be less than 450 mm from the surrounding ground level. A height of 600 mm is the best from drainage or other considerations. Parapet wall. Parapet walls and handrails provided on the edges of roof terraces, balcony, veranda, etc. shall be not less than 1.05 m and not more than 1.20 m in height from the finished floor level. Boundary wall. The requirements of the boundary wall are given below. Except with the special permission of the authority, the maximum height of the compound wall shall be 1.5 m above the center line of the front street. Compound wall up to 2.4 m height may be permitted if the top 0.9 m is of open type construction of a design to be approved by the authority. In the case of a corner plot, the height of boundary wall shall be restricted to 0.75 m for a length of 10 m on the front and side of the intersection, and the balanced height may be made up of open type construction, through railings, and of design to be approved by the authority. Minimum ceiling height standards for residential house. It is a fact that each room made with required or minimum height and size ensures that there is good ventilation, lights, and comfortable living inside the room. Standard size and height of the different rooms in the house vary depending upon location of the house, or it varies from country to country as per their local building bylaws and regulation. However, if there is no rule to follow, contractors and development, both public and private sectors, tend to reduce the size of dwellings being developed whilst trying to avoid any reduction in value. By law for minimum height and size standards allows well-planned and systematic construction of house and towns, and provide proper utilization of space. How ceiling height is decided. Human height in different position. Before deciding the minimum ceiling height, we need to understand human height in different positions in a room. As seen in the figure, the average human height is around 5 feet 5 inches. But, we raise our hand upward, it's around 6 feet 6. Maximum. So, considering this fact, the minimum height of the ceiling is taken. Minimum ceiling height in habitable room. As we know that the minimum height of door height is about 7 feet for all doors in the house. Each door of the house must have a minimum height of 7 feet. This is because of the fact that human average height is about 5.5 feet, and when we raise hand upward is about 6 feet 6 inches. So, there must be a gap between our hand and door frame bottom of the top frame. Nowadays, architects and engineers keep the floor to ceiling height about 10 feet in most cases. Again, let's understand this fact also. Total floor top to ceiling top is about 10 feet. Deducting the thickness of the slab becomes 9 feet 6 inches. Let's consider fan handing from the bottom of the ceiling is about 1.5 feet downward side, and when any men raise its hand toward ceiling straight, its height becomes 7 feet. So, the gap remains between men's hand and bottom of the ceiling fan will be equals 9 feet 6 inches. 7 feet 1.5 feet equals 1 foot or 12 inches. Therefore, from the above fact, we can conclude that the minimum ceiling height should at least 9 feet 6 inches for any habitable room in residential building. Minimum ceiling height in sunken slab of bath and W/C. Generally, sunken slab for bath and W/C is about 1 to 1.5 feet sunken below the slab. So, if total ceiling height is about 9 feet 6 inches, then space left below will be around 7 feet 6 inches. Therefore, the minimum ceiling height for bath and W/C sunken slab should be 7 feet 6 inches. Minimum ceiling height for various rooms in house. Living room/drawing room. The living room of any house is a place or area where the homeowners and family members gather to spend time together. It's an area designed for recreation but also for entertainment, space where guests are welcomed when visit. The living room, also termed as drawing room. The minimum ceiling height for the living room from the top of floor to bottom of the ceiling should be not less than 2.75 m or 9 feet 6 inches. In the case of an air-conditioned room, the minimum height should not less than 2.4 m or 7 feet 8 inches measured from the top of the floor to the lowest point of AC duct, or the false ceiling should be provided. Kitchen. The kitchen is the most important and essential room in any house because it is the center of your family's day-to-day living. Everyone's day starts in your kitchen with a cup of coffee or energizing breakfast to start your day. Kitchen space used to make meals for your family in your kitchen and probably even eat in your kitchen. As the kitchen area is a continuously used area of any house, its ceiling height should not be less than 2.75 m or 9 feet 6 inches. Bedroom. A bedroom of any house is one of a private room where people usually sleep for the night or relax during the day. It is estimated that humans spend our 1/3 life by sleeping, and most of the time we are asleep, we are sleeping in a bedroom. The minimum ceiling height of the bedroom should not less than 2.3 m or 7 feet 6 inches measure from top tiles to the bottom of the ceiling. Storeroom. The storeroom, sometimes attached to the kitchen, is the place for storing grains, foodstuff, and/or junk in the house for their ready availability and use in an emergency. The minimum ceiling height of the storeroom should not less than 2.3 m or 7 feet 6 inches measured from top tiles to the bottom of the ceiling. Bath and water closet. It is an area sometimes attached toilet and often a bathtub and a shower. The minimum ceiling height of the bath and toilet should not less than 2.3 m or 7 feet 6 inches measured from top tiles to the bottom of the ceiling. Garage. It is a place where house owner vehicle repaired, parked, serviced, and also used for storing used parts and accessories of the vehicle. The minimum ceiling height of the garage should not be less than 7 feet. But generally, it is kept more than 7 feet. Mezzanine floor. A mezzanine floor is an extra floor between two main floors, and therefore it is not counted on the main floors of any building. The minimum ceiling height of the room with the mezzanine floor from ceiling to top flooring of the ground floor is about 14 feet 4 m. Minimum ceiling height basement. The minimum ceiling height of the basement should be at least 7 feet to 10 feet. Standard height of window from floor level. The standard height of the window from floor level is an important point of discussion while constructing a new house or renovating an old house. The proper height of the window is very important for comfortable living as it permits the sun and natural air entry from the exact level. What is window? A window is one type of opening in the wall, which provides passage to pass light, sound, and sometimes air. Modern windows generally have glazed or covered with transparent or translucent material. The windows are the most important part of any house which provides light, fresh air, and ventilation in the house. Windows are also useful for the purposes of architectural decoration. The windows provided allows light into the room, enhance your wall colors or furniture. It provided seasonal utility like allows sun heat into the room and close the opening during summer to avoid outer heat to enter the house. Types of window. There are different types of windows available in the market. You can choose from them as per your requirements. The windows can have different shapes like square, rectangular, and even triangular. Some windows open outward, some slide up, down or slides one side to open. These types are available in different materials like wood, steel, aluminum, and PVC also used to make a window. Following are the 18 popular types of the window as listed below. Single hung windows. Double hung windows. Arched windows. Awning windows. Bay windows. Bow windows. Casement windows. Egress windows. Garden window. Glass block windows. Hopper windows. Jalousie windows. Picture windows. Round circle windows. Skylight windows. Sliding windows. Storm windows. Transom windows. What is standard size of window? Windows are a very essential part of any house. For a simple residential building or house, a minimum of 15% area of the room is allowed to provide for window openings. That means we can provide a window opening area around 15% of the room area. If the area of the room is 100 square foot, then we can provide one window with size 4 feet x 4 ft. For public and commercial building this is around 20% allowed. Width of the window depends on the factors like the dimension of the room, use of the room, location of the room, direction and speed of prevailing winds, climatic conditions of the region, and local trends, aesthetic view, etc. Following are some standard size of windows is mostly used in the house. The height of the window generally fixed, but it can be changed as per architectural and owner requirements. Windows height is fixed around 4 feet or up to the level of the door frame or lintel level. Standard height of window from floor level. The height of the window from floor level is also called the sill level of the window. So, there are two levels that are important while placing the window in position. Sill level. The level or distance from the floor to the bottom of the window frame is called the sill level. It is generally kept about 900 mm or 3 feet. Lintel level. the level from the top of the floor level to the top of the door frame on which lintel is placed is called the lintel level. The lintel is generally provided to avoid direct load on the wall and distribute above wall load to below load. The lintel is generally made up of reinforced concrete or cement mortar. Lintel level is provided as same as the height of the door, which is generally 2.1 m or 7 feet. So, the standard height of the door from floor level is 2.1 meter or 7 feet. It can be simply calculated by following calculations. Windows height from floor level equals height of door height of window. If the height of the door is 7 feet and the height of the window is 4 feet, then the height of the window will be equals 7 feet. 4 feet equals 3 feet. The standard height of window from floor level is 900 mm or 3 feet. It can vary depending upon the size of the window, ceiling height, and owner requirement. Types of doors for your perfect house. What is door? Doors are defined as the movable structure used for opening and closing an entrance or for giving access in or out of something. A frame used for giving access to indoor or outdoor as to a building or room, or giving access to a closet, cupboard, etc. Most doors turn on hinges, slide in grooves, or revolve on an axis. Importance of doors. We all know the proverb that the first impression is usually the last, and this is true especially for entrance to our homes. The entrance of any house creates a lasting impression on visitors' mind, but somehow doors remain unnoticed unless either they are elegantly done or completed in abbot shape. Doors are the major important element of any home. They do not only provide aesthetically pleasing but also have features like durability, strength, water, and heat resistance, and it should not warp with time. Past days have been gone. Now doors were used for the mere purpose of maintaining privacy and security. Nowadays doors become important aesthetic appearance, structure, and integral part of a home's interiors. Types of doors. Following are the major types of doors. Hinged doors, Dutch doors, pocket doors, roller doors, bifold doors, sliding doors, pivot doors, French doors, panel doors, PVC doors, flush doors, battened and ledged doors, bamboo doors, glass doors, aluminum doors, fiberglass door, fiber reinforced plastic doors, steel doors, louvered doors, swing doors, collapsible doors, sliding doors, rolling shutters, glazed / revolving doors, wooden or timber door, hinged doors. A hinged door generally made of either a solid wooden panel door or hollow cord door affixed to a door jamb with 2 or more hinges. These types of doors are too common and are useful in almost any application in which a door is required. These doors are generally located as front entry, rear entry, interior, and wardrobe doors. Dutch doors. A Dutch door, also known as double hung or half door sometimes, and is a door that's split in half horizontally, allowing the top half to open while the bottom half stays shut. Secure tight bolt holds the two halves together and it operates as a normal door. Nowadays, Dutch doors popular for their practicality as well as their old-world feel. These doors are the prime choice for interior doors as well, allowing you to keep an eye, an ear, on children and animals while keeping them in or out of a certain part of the house. Pocket doors. The special feature of pocket doors is that it gets disappear into a special cavity inside the wall when opened. These doors generally have top hung and slide along a track mounted on the ceiling. Many house owners choice for pocket doors simply because they like the style. The pocket sliding door is sometimes used to separate two rooms so that they may be joined as needed. Roller doors. Roller doors mostly used for garages and storage facilities, however they are an extremely trendy addition to a living room for instance. We can also utilize a roller door to separate the interior home from the deck or garden. Bifold doors. If you are looking for a seamless connection between inside and out of your house, choose bifold. Bifold would be the best option for your needs. Bifolding designs are not like Dutch or French, but they give stack neatly out of the way, providing gloriously open access to the garden and an expansive feeling inside. Sliding doors. Sliding doors are also known as bypass doors and are generally used for locations including large opening as that discovered in a bedroom or closets. Sliding doors do not swing open and rather, you have to move them on the track, and that's why they do not disrupt other components of the space. Therefore, just a part of the opening is accessible at a time. Pivot doors. The pivot doors are simply designed to rotate about its vertical axis. These doors are available with or without a stopper. This door can effortlessly rotate 360 degrees in its own axis, thus achieving an elegant swing in the space. The pivot doors are made with complicated hinges hidden on the top and bottom of the door, which forms the center from where the door rotates. These types of doors save space when it opens, covers half the portion of each space. French doors. A French door generally made up of one piece and has the light construction with glass panes extending for most of its length. They are also known as French windows. If you are searching for something different and eyes-catching, French doors would be the ideal choice. These types of doors have hinges set up on each side of the opening, and they swing to each other and fulfill in the center. They provide an unblocked view when both side doors are opened. Panel doors. In the past, panel doors are very popular for quite some time. Its name gives the idea about its making that the door is crafted not of one single piece of wood or other material, but instead is comprised of panels. Each panel later will fit together in order to create the finished door. It can have a 6-panel door that will be made up of 6 inset rectangles or squares within the door. In panel doors, a door can have one panel, or it can have several. The panel door can behave glass panes set into the wood as well in case you want to allow light through the door. Generally, panel doors are most suitable for exterior doors, but if you want a hair door that can better deaden sound, then you can have panel doors installed as interior doors as well. PVC doors. PVC or polyvinyl chloride is a very popular material choice for doors in your bathroom. These lightweight doors minimize your work while maximizing your investment. These doors look like painted wooden doors that do not need any maintenance, which is required for the absorbent, natural fibers of the wood. If you go for PVC shower doors, you'll find that they're simple to install and easy to clean. Flush door. A flush door is made of solid block board core, vertical stiles, and horizontal rails that create a prefixed frame, and block board is composed of wooden strips that are placed edge to edge and sandwiched between veneers. They bonded under high pressure and temperature using a synthetic resin. So, we can say that the flush door is a door that is made of a timber frame covered with ply from both sides. The hollow part left in is filled with rectangular blocks of softwood. Afterward, the final decorative finish is given by fixing the veneer on the top. It is named as a flush door because it has an entirely smooth surface, and if water splashed on its surface, it would simply flow off its surface without accumulating. Battened and ledged doors. These types of doors composed of vertical boards called battens, which are nailed or screwed to horizontal members called ledgers. The battens used are generally 15 to 18 cm wide and 2 to 3 cm thick. Normally, narrow battened doors have a better appearance. These doors can be either braced or braced and framed to offer rigidness and a much better look. Such doors are mostly utilized for toilets, baths, WC, and other rooms, as well as in homes where the economy is the prime factor to consider. Bamboo door. Bamboo strips can be used in doors and windows, including their frames and so on. One common option to the wood item is the jute coir composite board, which can be made use of for the manufacture of doors. Doors composed of bamboo jute have the benefit of being water resistant, rust resistant, termite resistant, environmentally friendly, biodegradable, and expense efficient. Glass door. Glass is most commonly used for windows and doors, primarily for paneling. It depends on owner whether like to use glass. Doors can be made out of glass for particular areas. Generally, glass doors' most suitable location is on the backside, as it offers an unblocked view of the yard or garden. Front doors made of glass also look gorgeous. However, care needs to be required to guarantee both personal privacy and sturdiness. Fixing one panel of glass set into wood frames are a regular and gorgeous alternative for front doors. Glass door is more expensive compared to others and needs more effort to upkeep. These doors have more weight than other doors besides being pricey. Aluminum doors. When you plan to give elegance look to your house, what types of door do you prefer? Perhaps the best choice for you would be aluminum. Aluminum doors already first choice option for contemporary architecture because of the security, aesthetics, and insulation properties it gives. As it well-known fact that aluminum is a durable and sturdy material that doesn't need too much maintenance. There is no doubt about the quality of aluminum. It has already been tested through a bit expensive. It's actually one of the best choices in the door market. Aluminum doors can be used for both residential and commercial purposes. It's perfect for glazing and glass fronts, providing you with a high-quality frame. Fiberglass door. Generally, Glass fiber is manufactured by bonding fiber with resin that can be utilized to produce a variety of products consisting of bathtubs, doors, and windows and so on. Fiberglass is proven to be one of the most solidified products with fairly low upkeep expenses as compared with wood and steel. Fiberglass doors are well known as steady as they do not warp, bow, or twist. Windows and doors made up of fiberglass can be offered with wood panels on the surface to surpass the visual appeals. Doors manufactured out of fiberglass can be utilized for both outside and interior areas. Fiber-reinforced plastic doors. Fiber-reinforced plastic has high strength. It can be put to numerous usages consisting of manufacture of doors. FRP doors are available in many colors and surfaces consisting of natural wood surfaces in the market. These types of doors may have two leaves of 1.5 mm density and leaves are molded over a core product forming a sandwich panel. FRP doors are one of the popular choice for modern-day house construction. Steel doors. Steel metal doors may be the first choice of doors when looking for doors for your commercial establishment, but they are some of the more versatile door options. Steel doors most suitable for exterior-facing doors that need to withstand heavy traffic and exterior elements. Nowadays, steel doors can also be installed in a residence, though they are more commonly used for stores, schools, and commercial buildings. Louvered doors. These types of doors are used when privacy with natural ventilation and quietness for rest is desired, as they allow free passage of air even when closed. Louvered doors can be used to help ventilate certain areas of your home, to add a small amount of privacy to otherwise open space, or as room dividers. Swing doors. Swing doors are much similar to hinged doors, but here the hinge can be rotated in either direction. In these types of doors, a shutter is fixed to the frame with double-action spring hinges which enables the movement on either side. It is made like that the slight force will open the door, while the spring action in the hinge brings the shutter to a closed position. The shutter return to its position is forced, so the door has to be fully glazed or put a peephole at eye level to prevent accidents. Collapsible doors. The collapsible doors are composed of vertical double channels, 20 x 10 x 2 mm, joined together with hollows on the inside to create an artificial gap. Channels are spaced about 100 mm 200 mm apart and braced with diagonal iron flats, which allow the shutter to open-close, giving an appearance of a steel curtain. The door's shutter operates within two rails, one fixed to the floor and the other at the lintel. Roller fixed on top supports the equivalent movement in both directions for easier operation. Sliding glass doors. These doors are generally utilized where there is space limitation for the swing of a hinged door or for aesthetic purposes. These doors are commonly used in commercial structures. The door's shutter slides horizontally along the tracks with the help of runners and rails. Generally, the door is hung by two trolley hangers at the top of the door running in a concealed track, while at the bottom rollers are provided to slide the shutter in the channel track. For providing easy movement, plastic rollers are fixed at top-bottom. Rolling shutters. Rolling shutters are generally used for shops/go-downs. This shutter works as a barrier and provides protection against fire and thefts, wind and hails. The rolling shutter is made of steel slabs called laths or slates, which are around 1.25 cm thick, interlocked with each other and coiled upon a specially designed pipe shaft called drum, mounted at the top. Such an arrangement is made that shutter moves in two vertical steel guide channels mounted at the ends. The channels may be made of steel sheets, deep enough to accommodate shutter and to keep it in position. The rolling door is raised to open it and lowered to close it. On large rolling shutter doors, more than 10 square meter, the action may be motorized. Glazed //. Glazed or slash doors are the same as framed paneled doors, except one of the panels is replaced with a glass to improve visibility of the interior room. Revolving doors. This door has a central shaft with 4 wings that hang on it. The shaft rotates around the vertical axis within a round enclosure. The door's central shaft is fitted with a ball-bearing arrangement at the bottom, which allows the shutters to move without any jerk and making noise. These types of doors may be fully paneled, fully glazed, or partly glazed. Wooden or timber door. These types of doors are primarily used for interior door applications. Timber is the oldest material used for the doors, and timber never seems out of fashion. There are many good reasons for using wood, such as wooden doors provide soundproofing, insulation, and security. They are easy to install and clean. They have a long life. Being a natural material, they have a different appeal. They do look elegant. They are very costly. How to reduce construction cost. Building a dream home is everyone's aspiration. Every one person wants to construct a home where they can cherish their memories. But when people want to make their dream into reality, it is very hard to fulfill. It is because house construction cost is not cheap nowadays. For the middle-class family is about investing their whole life income in building a home. That's why many people find it a large investment in their life. For this reason, they try to save as much as possible to get the optimum value of their price. Also, some people go for loans. That are why it is necessary to effectively use the money to get maximum benefit. It is not a big task nowadays to construct a low-cost house construction in India. Here, I am sharing some cheap construction methods and important tips on how to save costs while constructing your home. Selection of plot. This starts with selecting a plot for your home. Always go for a roadside plot where transportation facility and communication to every necessary center is possible, because that can reduce your transportation cost for a lifetime. But many sellers are there who take the opportunity of high demand and sell the roadside plots at a very high price. So be careful while choosing the plot. If you are getting it a little far from the main road, then it is okay. Conduct soil test. While selecting a plot, just not focus on the communication facility but do soil test, which is a much essential part of the construction. Because there are different types of soils are available, and each soil behaves differently. Before buying the plot, check the soil if it is a paddy field, agricultural field, or soil with hard soil. Because if the soil is not good or if it is a loose soil, then there you will have to expense a huge cost. And after, if it comes to know that plot having paddy field, then the foundation cost is huge, and again to get permission to make the home is huge. Confirm electrical and water supply in area. If there is no electric and water connection near your plot, then you have to apply for a separate pole connection near your home and have to make a separate connection for plumbing, which is again expensive. So look after these factors before buying a plot. Choosing construction materials. In any type of construction, building materials play a major cost-effective role. Among all the construction material, bricks, cement, rod, and sand make a large part of the construction material. If you purchase material in the lot, main one order for whole material, manner, then there will be less expenditure regarding construction material. Because the dealer will give you more discount as you purchase more amount of material. Prepare structural drawings. Preparing structural drawings for the house is essential. The majority of people ignore this and don't know about the structural drawings of buildings. They only thought about the architectural drawings of the building. But structural drawing is all about foundation plan detail, framing plan detail, column and beam plan detail, and other structural components of buildings. From this structural drawing, how much amount of rod, sand, cement, and bricks will be required can be calculated in advance. And if this is done accurately, then there is a chance of saving lots of money. Saving in finishing materials. Not only is the construction material only responsible for rising costs. Along with that finishing, the material is also responsible. While we consider finishing work, there is flooring material, doors, and windows, and especially wooden works for interior absorbs a huge cost. But this can be reduced if you are choosing proper material and buying material in bulk amount at a time. If you are purchasing this material in phase-by-phase manner, the shopkeeper may not give you a discount, but if you are purchasing in a bulk amount and from one shopkeeper, then you can save your money. Do not make change after construction starts. Sometimes people approve one plan before construction, and during construction, they suddenly change their plan. This is one of the major reasons, which again increases the construction cost. Try to avoid this thing unless and until it is necessary. Go for prefabrication work. To minimize the cost of house construction, you use modern technology. Use prefabricated parts for the construction of your home. In this type of construction, a part of the building is constructed at the factory or in a separate place and then combined to a site to make the house. It has a lot of benefits. It not only reduces the cost but also reduces the time of construction. Use fly ash instead of red bricks. If you want to reduce the cost, then choose to fly ash bricks instead of red bricks or other bricks. Fly ash bricks are less costlier than red bricks but have good strength for construction. It can reduce the cost of construction in a considerable amount. Select good color and putter. If you wish to reduce color cost, then go for lime-based color. Put the color twice to make the color brighter. Don't use putty. Generally, putty is often used when we need a smooth wall surface or the wall is very rough or there are larger sand particles showing. To avoid extra cost for putty, always purchase the standard size of sand for the purpose of plastering. If it is used according to standard size, you may not require to apply putty in your house, and it will save your cost. Buy material from local vendors. While purchasing materials for construction, try to purchase from local vendors because it will reduce your transportation cost, as the transportation of construction material is costly. Saving in labor cost. Labor cost is also a large part of the construction which cannot cut easily. But try to calculate the works in hours, how much labor will be required to finish work and how much time. In this way you can save your cost by estimating the labor cost, otherwise the labor will work according to their time and you have to expense more. Saving in machinery cost. Construction machines are always hired on a rental basis and their rental cost is too high. So try to take maximum advantages of construction machinery in a calculated way by which construction cost can be saved. Saving in flooring. Flooring can be done both costly or economically. Tiles come in a wide pricing range. Select one of them according to your budget. Also, cement flooring is a great option for reducing cost and one of the long-lasting flooring. Red oxide flooring is also a good option. Saving in wooden work. As far as possible, if there is no essential need for wooden work, try to avoid it. You can also try to avoid the use of costly woods for construction. Instead, you can use a jackfruit tree, wild jack, jungle jack, and similar wood most available in your place to reduce the total cost of wood up to 50%. Selecting good shape of house. The shape of the house also contributes to increasing the cost of construction. When the size of home increases, it increases the surface area and ultimately the cost of construction. So try design house such a way that it will reduce the surface area and reduce the cost. Reduce numbers of wall. Make the home more spacious by reducing the number of walls. It ultimately reduces the surface area and also decreases the cost. It also permits natural light to enter the house and decreases the number of electricity expenses. Few topics will discussed in next video. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.